Hello everyone, welcome back to my mathematics channel. Today I would like to teach you on tessellation, solving problems. So as you can see here, the shape of the beehive are actually repeating and there is no gap between each of the shape, right? So as you can observe, the bee is building their house in order systematically. That's amazing, isn't it? So this is actually one example of tessellation. So tessellation actually it means that the shape of the shape or the pattern is repeating without overlapping, and the shape are actually in order, in order with the same angle, same side, and exactly the same. Please keep on repeating non-stop, the same shape. So this is called tessellation. So today the main focus of this topic is explain the meaning of the tessellation, right? So now you can actually try to scan this one and you will see the pattern of the shape which is repeating without overlapping. Alright, so you can scan after this. So let's define what it means by tessellation. The structure of beehive is a tessellation, right? As I mentioned just now. So now why the beehive is a tessellation? A tessellation is a pattern of recurring shapes that fills a plane without leaving empty space or overlapping. So there are three important keywords. Recurring shape. Condition number one, it must be recur or repeat. The same shape must be repeat. Condition number two, there is no empty spaces. No empty spaces. And then condition number three is no overlapping. There is no overlapping between each of the shape, right? So let's see this one. This is an equilateral triangle. As you can see that the shape is actually repeating, right? The triangle is repeating. The yellow one is repeating, and the blue one or the green one is also repeating, right? So there is no gap between each of the triangle, isn't it? There is no gap between each of the repeating shape, and there is no overlapping. So this is called tessellation. So this one also another example of tessellation. As you can see, this one is repeating and there is no empty spaces between the shape and there's no overlapping, isn't it? So this is another example of tessellation, right? This is tessellation, this is tessellation. Then how about this one? Tessellation consisting of a combination of squares and regular octagons. Right, so you can see regular octagon is repeating non-stop. So this is another example of tessellation. And also you can see there is a square. There's a small square here, right? Is repeating. There are 6 actually and keep on repeating, right? So this is called tessellation. This is rhombuses, repeating rhombuses. This is repeating equilateral triangles, and this is repeating squares and octagons, right? So let's see this one. Determine whether each of the following tessellation or not. So as you can see, the shape is it repeating? And we have to check 3 conditions. So it seems like it's repeating. You can see this one is repeat, this one is repeat, right? And there is no empty spaces between the shape, and it's not repeating, right? So consists of pentagon only. So this is a tessellation consisting of pentagon, right? Pentagon. So now we look at B. Is this one a tessellation? Yes, it is. Or no, it is not. So it is not a tessellation because it has a shape which does not recur. Let's see which one. Square. The square is the only one. So this is not tessellation because the square does not repeat. The rest okay, triangle repeating, but the square is not recur, so it is not tessellation, right? So how about this one? Okay, let's study whether there is repeating or recurring shape and no spaces and no overlapping. Yes, it is a tessellation consisting of combination of equilateral triangles and squares. So you can see the squares, right? You can see the triangles. Alright, so this is yes, it is a tessellation. Okay, how about this one? This one is show that is actually a systematic pattern recurring. Alright, it is a tessellation consisting of recurring patterns without overlapping. Alright, so let's see this one. Exercise 5.4a. Determine whether each of the following patterns is a tessellation. This one, yes, it is repeating, no overlapping, and no empty space. So first thing, it must recur. The shape must be recurring, and then there's no empty spaces, and then it must have not overlapping. So it seems like it fulfills 3 conditions. 1, 2, 3. Yes, this is a tessellation. For B, this one is repeat. Okay, hexagon repeat, triangle also repeat, recurring, and no empty spaces and no overlapping, right? There's no overlapping between each shape. And then for this one, it seems like you can see that this shape is not recur, right? We can see square is recur, triangle is recur, but not the shape here. So this one is not recur. So this one is not a tessellation. Tessellation. Double S, double L. Okay, how about this one? So this one, as you can see, you have certain shape which, okay, is it recur? This one is it recur? We have this triangle. It seems like, okay, the shape are not so systematic, right? So we can say that this is not tessellation, right? Because the shape is not recur. Okay, so the triangle is inside there is not recur. So for D is not a tessellation. So this one is not a tessellation, and we can say that if we observe carefully, we have the shape, a small triangle here, right? It's not repeating. So this one also not tessellation. So we have only A and B. Yes, they are tessellation. All right. So this is the answer for you to explain why it is tessellation. Okay, so let's discuss question example 22. The diagram below shows a tessellation consists of equilateral triangle which are produced by isometric transformation. State the transformation involved to produce shape Q to shape P, shape R to shape Q, and shape S from shape P. Okay, let's see this one. So Q is the image of the P under the refraction of the line BC. Refract, right? This is object, this is image. The rotation of 60 degree. If you rotate this one's 60 degree each one, right? Because it's an equilateral triangle. So this is 60 degree. Okay. So R is the image of Q under refraction of the line. Line of refraction is here. This is the line of refraction. Let me underline. This is the line of refraction BD. The rotation of 60 degree anti-clockwise at the center D. Yes, you rotate. This is the object. This is the image. Okay, so S is the image of P under a refraction. Okay, so that means if we do refraction, this one will be the image, the purple one. This one will be image, and the object of the object is, I use the red color. This is the object. This one is the object. The red one is the object, and then the purple one is the image. And the rotation of 60 degree clockwise at point A. 60 degree clockwise at point A. So if we rotate the red one, we'll get the purple one. Rotation of 60 degree, center A. So we have to mention three. One is rotation 60 degree clockwise and center A. Image of P. Alright, have to mention the image of P. Under refraction, must mention the line AB. So we have two transformation. Okay, so that is how you answer for combined transformation. Okay, let's continue with exercise 5.4b. The diagram below shows a tessellation consisting of regular hexagons which are produced by isometric transformation. Isometric transformation. So we have to identify which one is the object. State the transformation involved to produce shape B from shape A. From shape A, that means shape A is an object. Okay, let's highlight this is the object. Okay, so this is the object. So from the object, how you transform the object to the image B. Okay, so the B is the image. So this one is the image, right? So actually we can do rotation, right? We can do refraction. So let's say we do easy one will be refraction. So we write here. Let's say we refract. So if we refract, let me draw the line of refraction. So we will refer this one as a line of refraction. Okay, so let's write a sentence. Okay, so we write refraction on line. So when refraction, we have to mention the line of refraction, which is PQ. Okay, all right, that is number one. So we can transform the object to A to image B by translation, right? Translation. Since this is 8 units, you see or not, this is 8 units, so here also 8 units, so it's minus 8, this is 0. Translation, we can say along the y-axis is 0, -8. Okay, so let's say this is x-axis, this is y-axis, this is x-axis. So we can say we shift down 8 units. Or we can say we do rotation. Rotation also can be accepted. So if we rotate, where is the point of rotation? Let's try to show how we rotate A to B. So the A is the object. Let's say for this line, we are going to rotate this line. Okay, this line. Okay, we rotate. We have to choose a point of rotation. Okay, point of rotation. Let's say we can choose point P, right? We can choose point P. We rotate this line. Okay, 120. This is regular hexagon. Okay, so it will come over here. The line, the red line. This, okay, let me highlight using green. This line will come over here. If we rotate 120, this direction is clockwise, so 120 rotation, 120 degree clockwise, right? Clockwise at center P. So we need to mention 3. One is the keywords rotation, followed by 120 clockwise, center P. Okay, 3 important keywords. Right, so this is how we actually transform A to B. How about if we transform a C from A? Okay, let's say now we want to transform A to C. So we actually can do rotation or refraction, isn't it? So if we refract, this is the line of refraction SR. Right, for the answer for the A to C, A is the object, C is the image. This is the image. Okay, this is the object. Let's say we want to transform object A to object C. So we will do refraction for sure, and line of refraction will be at the line which is just now I mentioned SR. This is the line. So refraction on the line SR. That is one answer. Okay, so we can write the refraction on the line SR. And translation, we actually if translate, because translate is along the x-axis and y-axis, so I don't think we can do translation. So we will do the rotation, right? Rotation we can do. Let's see how. So let's say I want to rotate A to C. So basically when we want to rotate A to C, we'll choose let's say this line S. We want to rotate R or rotate to this direction is anti-clockwise about center S. This is the center, so the R prime will be here. Okay, so the R will go there. So this is 120 degree because it's a regular hexagon. So rotation 120 degree, but it's anti clockwise, right? It's anti clockwise at center. Center is S, right? So we actually can have many answers other than rotation. Okay, again I show rotation this line. That means we are going to rotate this point. We are going to rotate this point, and then the center I will use the red one. Center I will use the red one here. Okay, so if we rotate, the green one will move, right? So this green point will move to, let me write the R prime using the blue color to show that this is the R prime. So the angle is 120 degree. Alright, so that is how we describe the transformation for the shape of tessellation. So in short, tessellation is quite easy. So we have to apply the transformation to describe the transformation of the recurring shape of the pattern of the tessellation. Alright, so that's all my sharing on how to solve the question involving tessellation. Till then, bye bye, and I shall share with you more exercise in my next coming video. Okay, let's have a look of this pattern. This is a very interesting pattern. Exe tessellation. Maurits Cornelis Exe was a Dutch graphic artist. He designed a lot of artworks based on the concept of mathematics. See how important is the mathematics if you want to become an artist. He introduced a unique and attractive way. Alright, unique and attractive way. So mathematics is so wonderful. Unique and attractive way to produce a pattern of tessellation, which is known as Exe tessellation. An Exe tessellation is a tessellation in which its shapes are easily identified in real life. Right? So this is one example of the shape that we can see in our daily life. You can see the star. You can see the star is repeating. It's repeating. But there is a gap between. It's not a gap. It's not a gap. It's a pattern. Right? The repeating pattern. See or not? There's no gap between them. So it's a tessellation. So the shape is keep on repeating, right? And there's no overlapping. You can see the shape is repeating and the star is repeating. Alright, and then this shape is repeating. It's very systematic. So this is one example of tessellation.